how to solve how to do thermal analysis in ANSYS. This is a 2D thermal analysis. As you can see, we have a rectangular block of 100 by 150 meters, and the coefficient of thermal conductivity of the material is 50 watt per meter square degree centigrade. In this problem, we are not going to consider the effect of convection. We are going to see only conduction effect on this block. Now let us perform a thermal analysis on this problem. First of all, go to preferences. These are the different modules which are available in ANSYS. As we are going to do thermal analysis, I'm going to select thermal. Okay, go to preprocessor, element type, add element. Add. As we are going to consider rectangular block, I'm going to select this solid. These are the different solids which are available for thermal analysis. I'm going to go with quad 4 node 55. Okay, close. As this is single material, no real constants are not going to consider. And go to material properties, material models, thermal conductivity, isotropic. In the given question, we have the coefficient of thermal conductivity as 50. So I'm going to select this 50. Okay, sorry, 50. Okay, close. Now let us start modeling. Modeling, create areas, rectangle by two corners. I'm going to take origin. Width of the rectangle is 100 meters and height is 150. While modeling it, be careful that all the units are in single form as ANSYS doesn't recognize any units. Okay. Now we got the rectangle. Now let us mesh it. Go for meshing. You can either mesh by using mesh tool or directly use mesh option from here. I'm going to select mesh here. Mesh the areas. As the rectangle is uniform, I'm going to select mapped mesh. Map 3 or 4 four sided. I'm going to select this area. Okay. As you can see, the mesh you have got is very coarse, but we want more finer mesh so that we can get more accurate results. So let us modify this mesh. Modify mesh, refine it. We have to refine this mesh at every single line. So I'm going to select lines. As we are going to refine this mesh at every line, I'll select pick all. This shows different levels of refinement. I'm going to select intermediate refinement, that is 3. Okay. Now you can see that this mesh is refined. Now we have to give loads. Before that, we have to check if this analysis is the steady state or thermal transient or any substructuring. So as this problem is under steady state condition, we are going to select steady state analysis. Okay. Now we have to define loads. Define loads, apply thermal, temperature on lines. We'll once again go to the problem statement. These four phases have different temperatures like 300, 200, 200 and 100. So now we are going to apply thermal loads on individual phases respectively. Select this one. This has a temperature of 300 degrees centigrade. Temperature 300. Okay. Now as these two phases have same temperature, I'm going to select them simultaneously. 200. Okay. Lines. This one has 100 degrees centigrade. This is 100. Okay. Now you can see that there are different thermal loads applied here. The next thing we are going to do is solving. As there is no effect of convection, I'm directly going for solution. Solution, solve, current load state. Okay, the solution is done. Now you can see your results either from list results or also plot results. Go to general post processor. You can see the values of the solution by list results, nodal solution, degrees of freedom solution, nodal temperature. In this, you can see the variation of temperature from phase 2 to phase 3. Okay. Okay, this is an nodal solution, nodal temperature. Okay. See, this is the variation of temperature from left side to right side. If you want to see it in a pictorial form or plot results, you go to plot results, contour plot, nodal solution, degrees of freedom solution, nodal temperature. See, this is the variation of temperature from this phase 2 to phase 3. The temperature is maximum here. This is obviously 300 degrees centigrade. It goes on decreasing here. It increases and also then decreases to the bottom. Now, if you want to see the variation of temperature with respect to certain path, then go to path operations, define a path by nodes. As we have done a refinement mesh, these are the nodes which are available in place like this. You plot the nodes like this so that you can see the nodes clearly and get variation of temperature with respect to nodes. I'm going to let us see the select these nodes first. One, let us name this as temperature. Okay, close. Now go to map onto path temperature. Okay, now plot path on graph. Select this temperature one. Okay, this is the variation of temperature with respect to that. I didn't select the middle one exactly, so this is not exactly symmetric. If you select the middle one, you're going to get symmetric. You can define new path or any select any nodes on which you want to get temperature. This is the thermal analysis of the rectangular block. Thanks for watching. Please subscribe.